In this lecture, we will try to understand polynomial addition using linked list. In this particular program, we have three functions. First function is polynomial poly underscore addr, and the second function is enter function, this one, and our third function is insert function. In these three functions, I will discuss about enter function and insert function. In my next lecture, I will discuss about poly underscore add function. Here we have to represent polynomial in terms of single linked list. How can I represent a polynomial using single linked list? To represent polynomial using single linked list, I need a structure. Here struct space structure name node. This is the structure which we need. In this structure, we have three members. First one is coefficient, float coefficient, int exponent, struct node star link. In this structure, we have three variables in which first one is coefficient variable, second one is exponent variable, third one is link variable. In these three variables, link variable is known as pointer variable. This one as usual self-referential structure. Yes. Now just see this one. After this structure, as we discussed, we have three functions. First function is polyadd, second function is enter, and third function is insert, in which I will discuss about this enter function and insert function. As I told you, I will discuss about poly underscore add in my next lecture. Now, as usual, this main, where is our main? This one is main, which indicates beginning of your C program. This is the main beginning. Struct node spaces star p1 underscore start, p2 underscore start, p3 underscore start. All these three variables are pointer variables whose data type is struct node, isn't it? Yes. All these three variables, p1 underscore start, p2 underscore start, p3 underscore start, are initialized with null values. Now printf polynomial 1. After displaying this message, my intention is I have to represent this polynomial. Which polynomial? X power 8 plus 5x power 4 minus 7x square plus 6x by using linked list. As I discussed in my previous lecture, how can I represent this particular polynomial? Yes, what we need? We need coefficient and exponent. In the case of 1x power 8, 1 is coefficient, 8 is exponent. That's what it says. Coefficient 1, exponent 8. What about next one? 5x power 4. Coefficient is 5, exponent is 4. 5, exponent is 4. What about minus 7x square? Minus 7 is coefficient, 2 is exponent. What is 6x? 6 is coefficient, 1 is known as exponent. How can I write program to represent this polynomial by using linked list? We will try to understand. Yes, where we are, printf polynomial 1. Enter is a function through which we are passing a pointer variable p1 underscore start. What is the value of p1 underscore start? Null. Initially its value is null. Therefore, we are passing through this function. This is function call or calling function. Automatically control will transfer. Where will it transfer? Control will transfer. Where is that function? This is the function, isn't it? This p1 underscore start is null. That null value will be copied to this null pointer. Therefore, what is the value of start? Start equal to null. I, N, E, X are integer type variables. CO is coefficient is float type variable. Printf, how many terms you want to enter? As I want to represent this particular polynomial, 1, 2, 3, 4. Therefore, in this polynomial, I have 4 terms. First term, second term, third term, this is third term, and fourth term. Let me say how many terms you want to enter means, let me say I entered number 4. that number 4 will get stored, in the place of n. Therefore, my n value is 4, isn't it? I equal to 1, 1 less than or equal to 4, correct. Enter the coefficient for term percentage d. What is my I value? I value is 1. Therefore, enter coefficient for term 1. What is my term 1? 1x power 8. 1x power 8, what is a coefficient? What is exponent? Here we are asking about coefficient. Therefore, let me say I entered number 1. Scan of double quotes percentile f ampersand CO. Here my CO value is, what is my CO value? 1. Printf enter exponent for term percentile d. As I is 1, enter exponent for term 1. What is my exponent here? 1x power 8. 8 is exponent. Let me say I entered 8. That number 8 will get stored in the place of ex. Therefore, here we have values CO equal to 1, ex equal to 8. Yes, this insert is function call or calling function. What is my start value? Start value is null, isn't it? Here we pass null value from p1 underscore dot start means p1 underscore start means null. That null value is copied to this start. Therefore, we are passing 3 arguments. First argument null, CO is 1, ex is, CO is 1. What is the CO? This is value 1 and ex is 8. Null 1 8. As it is function call or calling function, automatically it will transfer to the definition of its function. I kept the definition in next slide. Let me go to the next slide. Now, what we were passing here, this one is, what is this? Let me choose pen first. Yes, let me select pen. Now, what is my start value? The start is null, isn't it? Have you remembered that? This is null. What is coefficient value? We passed 1, 1x power 8. Ex value is 8, isn't it? Now, where we are? Struct node star PTR star TMP. TMP equal to malloc size of struct node. Internally, what happens? A pointer, a node will be created. How will it be? In this node, what are the fields? In this particular structure, what we have, even you can see in previous slide, what fields you have here? You have coefficient field. Here you have, just see, this is coefficient COEF, EXPO link. These are the fields COEF. Just remember COEF. This is first slide. COEF EXPO link. Let me go to next slide. COEF EXPO link. This one is, what is this? COEF EXPO link, isn't it? This is COEF means coefficient. What about next? EXPO, I think it's EXPO exponent, and third field is link field. Let me say this node address is 1000, isn't it? Yes, because of this TMP equal to malloc size of struct node, internally this node is created. TMP arrow COEF, this is TMP node. Just now we created this node name is TMP node. TMP arrow COEF, TMP arrow COEF means this one, equal to CO. What is my CO value? Coefficient value 1. Yes, TMP arrow EXPO. TMP arrow EXPO. What is my EXPO value? EXPO value is EX. EX is 8. That number 8 will be copied to EXPO. Now, TMP arrow EXPO means this number is 8. Let me say this is 8. Isn't it? Now, where will I go? If start equal to null. Yes. So, what is my start value? Null. Null equal to null. True. If any one of this is logical OR. If one condition is true, that's enough for me. Therefore, as start equal to null, null equal to null true, we will enter inside if block. TMP arrow link. This one is TMP. This one is arrow link. Here I must keep start. What is my start value? Start value, just see here, start is null. Therefore, I must write null here. Isn't it? Now we created one node. Now what happens? TMP arrow link equal start. Start equal to TMP. What does it mean? Start equal to TMP means I can write start is a pointer variable. Otherwise, let me write here start equal to TMP. What is your TMP value? TMP means 1000 Therefore, let me write start equal TMP means automatically it will point to a node whose address is 1000. Isn't it? That is start equal TMP. After executing this if block, will you enter inside else? No, you cannot enter inside else. Now, where will you go? Return start. Return start means you will go back, just go back to the, what is your start value here now? Start value is 1000. You are returning 1000. You will go back to the first slide. In first slide, now previous value of I is 1. Now I becomes 2. Isn't it? Now I becomes 2. Let me choose pen. I equal to 2. I plus plus means I equal to 2. Now enter the coefficient term 2 and means enter the coefficient for term 2. In term 2, let me say this is 5x power 4. Let me say I entered 5. This 5 will get stored in the place of CO. Enter exponent for percentage means here I equal to, for term 2. Term 2 exponent is 4. Therefore, this 4 I must write here. Where will I write? Therefore, this is 4. Means what is my CO value in this here? CO coefficient is 5. And what is my EX value? EX value is 4. As 5x power 4, 5 is coefficient CO, 4 is exponent. This insert is a function. This through this function, what we are passing in the, what is start value now? Already previously start is written, that is 1000. Let me say this is 1000. COE is 5. EX is 4. 1054. Let me go to the next slide. 1054. This must be what it is. Let me choose pen. Now this cannot be null. This is 1000. 5x power 4 means this is 5. X power 4 means this is 4. Isn't it? 1054. Now where will you go? Struct node star PTR star TMP. TMP equal malloc size of struct node. Internally what happens? A node will be created. With how many fields will it create the node? With COEF, EXPO, link. Let me say this address is 2000. Now this cannot be TMP. Now which one is TMP? Otherwise, okay, let me write this one is TMP. Isn't it? Yes. Now where can I go? TMP equal malloc size of struct node. TMP arrow COEF. This is TMP arrow COEF equal to CO. What is my CO value? CO value is 5. Therefore here 5 must be stored. TMP arrow EXP. This is TMP arrow EXP equal to EX. EX means what? Here EX means 4. Isn't it? EX is 4, CO is 5. Therefore, it must be 4. Isn't it? Now, where will I go? If start equal to null, what is my start value? Start value is 1000. 1000 equal to null. If this is logical OR. Logical OR means 1000 equal to null. Is it true? 1000 cannot be null. EX. What is my EX value? 4. Your EX value is 4 is greater than EXPO. What is my EXPO? 8. EX greater than EX is, what is my EX value is 4 greater than start arrow EXPO. What is my start? 1000. 1000 EXPO is 8. 4 greater than 8 false. This one is false. This one is false. Again this one is also false. We will not enter. We will not enter inside. We will not enter inside if black. Isn't it? We will not enter inside. We will not enter inside if black. Now where can I go? Where can I go? This if black is skipped. If it is skipped, where can I go? If it is skipped, where can I go? Just let me choose pen. Yes, we will enter inside else. PTR equals start. What does it mean? PTR is pointer variable. What is start? Start is 1000. Therefore, here I must keep PTR equal 1000. This is PTR equal start. This one. PTR equal start means again where will I go? Here I must go. While PTR arrow link not equal to null. What is my PTR? 1000. 1000 link null. Null not equal to null. Null not equal to null. False. Logical AND means both conditions must true. If one of them is false means this logical AND is false. Therefore, this immediate statement will be skipped. Therefore, this particular code will get executed. What it says, TMP arrow link. What is my TMP? TMP means what? 2000. Therefore, 2000 link. TMP arrow link equal to PTR arrow link. What is my PTR? 1000. What is 1000 link? 1000 link is null. Therefore, this null will get stored in 2000 link. Here I must write null. Isn't it? Yes, it's null. TMP arrow link equal to PTR arrow link equal to TMP. PTR means what? 1000. What is 1000 link? This is 1000 link. Equal to TMP means 2000. Isn't it? This code PTR arrow link equal TMP. PTR means what? 1000. 1000 link equal TMP. Let me remove null. After removing null, I can keep, what can I keep? I can keep here TMP. Isn't it? What it says? Let me choose pen first. Yes, this particular code PTR arrow link equal TMP. PTR means what? 1000. 1000 link equal TMP means 2000. Therefore, I must write here 2000. Automatically, it will search for a node whose address is 2000. Return start. What is my start value here? Start value is still 1000. Therefore, I will go back. After going back, this must be previous value of I is 2. Now I becomes 3. Let me choose pen first. Otherwise, erase. Let me erase this. Yes. Previous value of I is 2. Now I becomes 3. Isn't it? I becomes 3. Let me erase this one also. Let me choose pen. Yes. Now I equal to what? 3. I plus plus. Previous value of I is 2. Now I becomes 3. I plus plus means 3. 3 less than or equal to n means 4. Yes, 3 less than or equal to 4. Means coefficient for term I equal 3 means for term 3. What is my term 3? This is my term 3. For term 3, what is coefficient? Minus 7. What is exponent? 2. Therefore, coefficient is minus 7. What is my exponent? My exponent is 2. Isn't it? Now, which one we are passing? Start. As usual, start is 1000. What is my coefficient value? Minus 7. And exponent value is 2. Therefore, CO equal to minus 7. Ex equal to 2. Minus 7x square means coefficient is minus 7. Therefore, exponent is 2. Now, where will you go? You will go to the next slide. Minus 7 comma 2. This one must be, let me erase first. Let me erase this. This one, minus 7 comma 2. Minus 7 comma 2 means, let me choose pen. CO is minus 7. Ex2 as usual start is 1000. Isn't it? Now where will I go? I will enter inside this particular function. TMP equal to malloc size of struct node. TMP equal to malloc size of struct node means internally a node will be created with that 3 fields. What is my first field? COEF coefficient. Next one is EXPO. Next one is link. Now what happens? This, let me say this one is 3000. Isn't it? Now where will I go? TMP arrow COEF. Now this cannot be TMP. This cannot be TMP. This is TMP. This is TMP. TMP arrow COEF. TMP arrow COEF equal to CO. What is my CO value? Minus 7. Therefore, it must be minus 7. TMP arrow COEF equal TMP arrow EXPO. TMP arrow EXPO equal to EX. What is my EX value? 2. This must be 2, isn't it? Yes. Now where will I go? If start equal to null. If start value 1000 cannot be null. Or EX. What is my EX value? 2. EX value is 2 greater than start arrow EXPO. What is my start? 1000. 1000 exponents is 8. 2 cannot greater than 8. This if block is skipped. Now where will I go? I must go to else block. Yes. Now again PTR equal to start. PTR equal start. Start means 1000. As usual, it will point to the first node. While PTR arrow link. What is PTR arrow link? 1000. 1000 link is 2000. 2000 not equal null. True. And PTR link. PTR means what? 1000. 1000 link is 2000. PTR link means 1000. 1000 link is 2000. 2000 EXPO. 2000 EXPO means 4. 4 greater than EX. What is my EX value? 2. Correct. 4 greater than 2. It's true. This one is true. PTR arrow link, 1000 arrow link, 2000 not equal null true. And this 4 greater than 2. Logical end means what? Logical end means if both of them, both are true. Both are true means what can I write? Both are true means this while loop is satisfied. If while loop is satisfied, now where will I go? Where will I go? Just a minute. Let me choose pen. Yes, this condition is true. This particular condition is true. And this particular condition is also true. True and true is true. Therefore, in while loop body, how many statements are there? There is only one statement. There is only one statement. There is only one statement. Why? Because we are not keeping flower braces. Therefore, this particular statement will get executed. What is that statement? PTR equal to PTR arrow link. PTR equal to PTR arrow link. What is my PTR? 1000. 1000 link is 2000. Now this PTR is updated with 2000. It will point to a node whose address is 2000, isn't it? Again, you will go back. Where will you go back? Again you will go back to the loop, isn't it? You will go back to the loop. What is the loop? Just a minute. Yes. Now PTR arrow link. PTR arrow link 2000 link. What is my 2000 link? Null, isn't it? Null not equal null, false. If one of them is false, you need not bother about other condition. False and something is always false. Therefore, this while loop will be terminated. Means immediate statement will be skipped. Means this statement will not get executed. Now this particular statements will execute. We will try to understand this. What it says. TMP arrow link. TMP arrow link means what? What is my TMP? Here TMP is, just a minute. This cannot be TMP, isn't it? Our TMP is recently created node, isn't it? Yes. Now where we are? TMP arrow link. TMP means what? 3000. 3000 link. This is TMP arrow link. This is TMP arrow link. Means this one. TMP arrow link equal to PTR. What is my PTR? What is my PTR? TMP arrow link equal to not PTR. PTR arrow link. PTR means 2000. 2000 link is null, isn't it? TMP arrow link. TMP means this one. Arrow link means this field. Here you must keep PTR arrow link. PTR means 2000 whose link is null. Therefore, here I must write null, isn't it? Yes. This one is over, completed. PTR arrow link equal to TMP. Just see this one. PTR arrow link means PTR means 2000. 2000 link equal to TMP. What is my TMP? 3000, isn't it? 3000. TMP means what? Recently created node is this. This I must write here. Let me erase that first. How can I erase? Yes, this will be removed. Yes, I think this can be removed. Now what will I write? This anyway, this code is also we discussed. Let me choose pen. Now 2000 link equal to 3000. Here I must write 3000, isn't it? It will search for a node whose address is 3000, isn't it? Now where will I go? This particular code executed. Now let me erase this. These are not required. Anyway, we are updated in PTR equal to as 2000. This also is not required. This one is also not required, isn't it? Now where can I go? This one is, we completed this. Now where will I go? After executing this, we will go back. After return start. Return start means let me go to the first slide. Previous value of I is 3. Now I becomes, let me choose pen first. Now I becomes 4. I becomes 4. I plus plus. 4 less than or equal to n is also 4. 4 less than or equal to 4. Correct. I is 4. Since I is 4, this is not there. I is 4. Enter coefficient term 4. Enter coefficient for the term 4. What is term 4? 6x. What is the coefficient? 6 is coefficient. 1 is exponent. 6, 1. Therefore, coefficient, what can I write? Let me erase these things first. Let me erase this also, this. Yes. Now where we are? Now where we are? Just a minute. Let me choose pen. Yes. Now 6, 1. What is my coefficient? 6. What is my exponent? 1. This is 1000. 1000. What is CO value? CO value is 6. Exponent value is 1. Function call. We'll go to the next slide. 1000, 6, 1. 1000. This is 1000. Let me choose pen. Let me choose pen. 1000. Starting node address. Code 6x power 1 means 6. Exponent 1. As usual, what happens? Struct node star ptr tmp equal malloc size of struct node. Means internally a node will be created. With how many fields? With 3 fields. What is my first field? COEF, coefficient. What is my next field? EXPO. What is my next field? Link. Let me keep address some 4000 this particular node. Yes. After creating this node, TMP arrow COEF. Now this cannot be TMP. This is TMP. What it says? TMP arrow COEF equal to CO. What is my CO value? 6. TMP arrow EXPO. TMP arrow EXPO, this one. What is this value? EX. EX is 1. Isn't it? Now, where can I go? If start equal to equal null, it's not true. Else, PTR equal start. What is my start value? 1000. Isn't it? Now, let me erase all this. Yes. Let me write again. Yes. Let me choose pen. Yes. Else PTR equals start. PTR is a pointer variable where I can store start. Start means what? 1000. It will point to a node whose address is 1000. Isn't it? Yes. Now where we are? PTR arrow link. 1000 link. 1000 link is 2000. 2000 not equal to null. Correct. PTR arrow link. PTR means 1000. 1000 link is 2000. 2000 EXPO. 2000 EXPO means what? 2000 EXPO is 4 is greater than, what is my EXP value? 1. 4 greater than 1, true. PTR arrow link not equal to null, true. Both of them are true. Now where can I go? Where can I go? PTR equal to PTR arrow link. What does it mean? PTR equal to PTR arrow link means PTR equal to, PTR means what? 1000. 1000 link is 2000. Now PTR will be updated with 2000. Now PTR value is 2000. First let me erase existing link. Therefore let me erase this one first. Let me erase number 1. Now PTR is updated with 2000. Let me say here this is 2000. Automatically it will search for a node whose address is 2000. Now where can I go? Now where can I go? PTR equal to PTR arrow link. Again I will go back to the while loop. PTR arrow link. PTR means PTR arrow link. PTR means what? 2000. 2000 link is 3000. Not equal null, true. And PTR arrow link. What is my PTR? PTR is 2000. Here 2000 link. Isn't it? Here PTR is not. What is a PTR here? Let me remove this. Remove this also. Let me remove. Now just we will try to understand. Yes. What is my PTR? 2000. What is 2000 link? 3000. Here I must write 3000. 3000 EXPO. 3000 EXPO is 2. 3000 EXPO is 2. Is greater than EX. What is my EX value? 1. 2 is greater than 1. It's true. It's true means what? PTR equal to PTR arrow link. PTR equal to PTR arrow link means PTR is 2000. 2000 link, it will be updated with 3000. Therefore, this must be PTR is updated with 3000. Therefore, PTR will point. Where will it point? It will point to a node whose address is 3000. Therefore, now where it can point? It will point to a node whose address is 3000. Isn't it? That's what it says. PTR equal to this one. PTR equal to PTR arrow link. Now where will I go? Again I must go back here. What it says? PTR arrow link. PTR means what? PTR means 3000. 3000 link is null. Null not equal null false. And a logical and means if one of them is false, while loop will be terminated. This immediate statement will be skipped. Now this which one will get executed? Let me erase first. let me erase this also, let me erase. Now just see. Yes, let me choose pen first. Yes, PTR is 3000. 3000 link is null. 3000 link is null. Therefore, null not equal to null. Null not equal to null. False. While loop will be terminated. Therefore, this particular two statements will get executed. What it is? TMP arrow link. What is my TMP? This is TMP. What is TMP arrow link? This field equal to PTR arrow link. What is my PTR arrow link? PTR 3000. 3000 link is null. Therefore, I must write here null. Isn't it? TMP arrow link equal to this one I completed. Now, PTR arrow link equal to TMP. This one. PTR arrow link equal to TMP. What is my PTR? PTR is 3000. 3000 link. 3000 link equal to TMP. TMP means 4000. Isn't it? Therefore, 3000 link. Here I must write 4000. How can I write? Just see. First let me erase this one. Yes. Now, yes, this cannot be temp also. Now, let me choose pen. 3000 link. 3000 link, this one. Here I must write 4000. Automatically, it will search for a node whose address is 4000, isn't it? Now what happens? Return start. Again you will go back. Again 1, 2, 3, 4. Now I becomes 5. Now I becomes, let me erase all this, otherwise erase. Let me erase this also. Just a minute. This also let me erase. Now this can be erased. This can be erased. Yes. Now anyway, let me choose pen. Where can I go? Yes, here I value becomes 5. I is 5, your n is 4, 5 less than or equal to 4, false. For loop is terminated. Return start. Isn't it? What is my start value? 1000. This 1000, where will it go back? This 1000 will be stored P1 underscore start. Now my P1 underscore start is 1000, isn't it? Isn't it? Now P1 underscore start. Let me say here we have a pointer. Here we have a pointer P1 underscore start equal to start means this is 1000. It will point here. What we did till now, we created how many nodes? This is, we created 4 nodes. We created 4 nodes. We created this node. This node we created. First node. This is second node. This is third node. This is fourth node. Yes. This P1 underscore start is a pointer which is pointing to the first node. In order to understand polynomial addition or subtraction programs, first we must represent, that may be addition or subtraction programs, first we must represent these polynomials using linked list. This is 1x power 8 plus 5x power 4 minus 7x square plus 6x power 1. In similar manner, I can represent one more polynomial using linked list. So in similar analogy, you can understand representing one more polynomial using linked list. Once if we have understanding of representing polynomials using linked list, performing arithmetic operations, that may be addition or subtraction, are simple. In my next lecture, I will explain how to add 2 polynomials using single linked list. Thank you very much.